Hi guys, in this video we're going to have a look at 3D Pythagoras. So if you haven't looked at my Pythagoras video, definitely give that a look first because we're going to be building on that. And the second thing to say is that this is a tricky topic. Not so much in the maths involved because it is just the same as Pythagoras, but actually visualizing what's happening and what the actual question is asking. That is quite tricky. So the most standard type of question is the one that I've got here, where we're dealing with a cuboid. And the question asks us, work out the length between E and C, which is this corner here and this corner here. So if you can imagine my little diagram here, so this is the cuboid, obviously not to scale. What we're after is from this corner here to this corner here. So this one here to that bottom one, so we're going diagonally across like that. Okay, or actually I've done my labels here, so that's A at the bottom, that's E, and then this would be C. So I'm going diagonally from the top here to the bottom down there. And this is quite tricky to visualize. So the first thing I recommend you do is you actually draw the line from E to C like so. Okay, and what we were after doing is creating a right angle triangle. So I'm going to come straight down there. So just from E to A, and then I'm going to go from A to C, like so, like that. And then what I recommend you do is actually colour that in, because it makes it a little bit easier to see that it is a right angle triangle, which I'm just going to very quickly do now. I might have to twist it around, there we go. The old highlighter out. Bit of colouring skills never goes amiss. There we go, that'll do. Okay, so there you can see that I've actually drawn my right angle triangle in the middle of my cuboid. So the next thing that I recommend you do is just to re-sketch that somewhere else. It doesn't have to be accurate, just a right angle triangle of some description. So I'm just going to do one like this. Okay, and label it so you don't get confused. So the top one there is E, the bottom one there is A, and then this one here is C. Excellent. Now with Pythagoras, if you say, like if you've watched the previous video, you need to have two lengths to work out the other length. We need to work out E to C, so I need to know that what these two lengths here are. Well, E to A is nice, that's given to us. That's 2 centimetres. But what I don't have is the length A to C. So hopefully you might have already spotted it. I need to draw another right angle triangle. And I'm going to just colour that in to hopefully make it a little bit easier to see that you have another one there. And I would definitely recommend doing this in the exam just because it just makes it a little bit easier to visualise what's going on. Or if you do have a pencil case that is in the shape of a cuboid, that does tend to help as well. Okay, so there we go. So there's my two right angle triangles. So if I just bring back my little diagram here, here is our cuboid. As you can see, I've got A, B, C, D at the bottom, which is the bottom rectangle there. So all I've done is I've got my blue triangle there, which is the length from A to C. So there's my right angle triangle there. So let's draw that one out just like we did with the first one. Again, just a quick little sketch, it's just to make the calculation just a bit easier. Where we have A at the bottom, B at the bottom, and C at the bottom. And this length here is 3 centimetres. This length between B and C is 4 centimetres, in which case, because we have the two lengths, we can now work out what A and C is. So just like you would have done before, so 3 squared plus 4 squared is C squared, and then you can square root it, or I quite like drawing the little diagrams here. So what's the area of that square? that's going to be 9 centimeters squared, because you just square 3. Same with this one here. 4 squared is 16 centimeters squared. I'm not going to do a complete square there because it'll take up too much space. Then we add them together. 9 plus 16 is 25 centimeters squared. Don't forget to square root it to go back to the length, which in this case is 5 centimeters, making it a Pythagorean triple. Awesome. So I now know that AC is 5 centimeters, so I can put that in there. So I now know that that length across there is 5 centimeters. So now when I have my orange triangle and I put that in like so, you can hopefully see that I now have the base length, the bottom of that orange triangle, which is the AC, and of course I have the height of it because it was just the height of the cuboid there. So apologies, it's not very good. If I ever tilt it like that, you can get the idea of what I'm trying to do. I'm trying to get that right angle triangle in the middle of that cuboid. So now I've got the length AC, I can just do exactly the same thing, just draw a very rough there. So the area of this 2 squared is 4 centimeters squared. Again, would be a square. 5 centimeters squared is 25 centimeters squared. And because we're after the hypotenuse, that longer length there, we add them together. So 4 plus 25 is 29 centimeters squared. Don't forget to square root it. So the square root of 29, I will use a calculator just to make sure I can get it to 1 decimal place. So square root of 29, 5.38. I'm going to round it to 1 decimal place, so 5.4 centimeters. Okay, so hopefully that shows you what we're trying to attempt when dealing with 3D Pythagoras. We're trying to make right angle triangles inside the shape there. So that's a very common type question. However, there are some other ones that may come up, which we're now going to have a look at now. So just bear with me a second. Okay, what they could ask you is something like this, where you have a pyramid. In this case, it's a square base pyramid, which is crucial to the question, and you need to work out the height. So the first thing I'm going to do is draw the height, and then I'm going to try and make a right angle triangle. So to do that, I'm going to go to one of the corners like so, and again, what's a good idea is to draw it to try and make it a bit more visually easy to see what's going on. So I'll just draw that on there. Like so. There we go. So there you can see my right angle triangle, which I'm now going to use Pythagoras. And just like before, what I recommend you do is just do a very quick sketch. So I'm just going to make this one just a bit taller, just to sort of try and mirror the diagram. Okay, there we are, lovely. Okay, so we know that we're told that the slanted heights there are 15, so I can put that there, that's not a problem. I'm after the height, so I need to know what this length is here, this bottom length here. Unfortunately, I don't know what that is, so I need to try and make another right angle triangle. And the question here says it's a square base pyramid, so the base here is a square. So if I go diagonally across like so, I have then made another right angle triangle here, because the corners of a square are right angles. And again, I'll just colour that in just so you can hopefully see it a bit easier. Let's turn it around, makes it a bit quicker. There we go. Okay, so on the bottom there of my square, I've just cut it in half, so then I have another right angle triangle that I'm able to then use Pythagoras on. So I'm just going to do a very quick sketch of that. I'm going to use these sides to be the same because it's a square base pyramid, so I'll just do those 3 by 3, but it's just a sketch, but if they're the same it sort of makes it a little bit easier to see what's going on. And that length there is 9, and because it's a square, this length here is also 9, which allows me to work out this length here. So again, however you do your Pythagoras, either formula or drawing, it's entirely up to you. 9 squared is 81 centimetres squared. 9 squared obviously is the same, 81 centimetres squared. So what is the area of this one? Let's get the calculator ready so I can do my square root. So 81 plus 81 gives me 162 centimetres squared, and then I can square root it, so I can square root my answer or just do square root of 162, which gives me square root of 162, which gives me 12.7279, etc, etc, etc. Now don't get rid of that, keep that on your calculator, because what we've just worked out is that whole length here. I don't want that whole length, I just wanted half of it, okay, which would be my bottom of my triangle here. So what I'm going to do is divide that by 2, which is going to tell me that 6.363961,031. Now again, don't get rid of that, because we want to try and make this as accurate as we possibly can. So I don't want to have to type that in again, and I don't want to round it. I don't want to round anything until my very last answer. So what I'm going to do is I'm going to do 15 squared. This is now the hypotenuse, so that's the big side. So I'm going to do 15 squared, take away this squared, but because I've already got it on my calculator, what I can do is use the answer button, squared, and get an answer. So let's type that in. So 15 squared, which is this area here squared, minus my previous answer, which was this, squared, and that equals the area of this one here. Okay, which is 184.5 centimetres squared. Of course, I don't want that. I need to get the length h, so I square root it, giving me an answer of 13.583, etc, etc. So round it however the question says. I like always one decimal place, which would be 13.6. So to answer the question, we have 13, or the height is 13.6 centimetres. Okay, so again, it's just another way of using Pythagoras, but in a 3D shape. I've got one more example to show you. So let's have a look at that, which is this one here. So it's a very similar type of question. Calculate the height, this time of the hexagonal pyramid. So the base here is a hexagon. You can see by these lines that it's a regular hexagon because all these sides are the same. And just like before, we need to work out the height. So again, I'm just going to draw the height there. And as before, I'm just going to draw from the center to a corner, so you can see that I've created a right angle triangle. Again, just colour it in if it helps. If it doesn't, don't worry about it, you don't have to. Sometimes it does make it a bit easier to see what's going on. There we go. Okay, so that's what I'm after. Once you've identified you've got your right angle triangle, let's just draw a little sketch over here to do all of our working on. Like so. And this time we're told that the slanted height is 11 centimetres. We're after the height. And just as before, I don't know this. Now the difference with this is that because it's not because this is a hexagon, the base here, and not a square, if I go across there, what I've actually created is a trapezium. So that doesn't actually help me. However, if you just draw a quick sketch of a hexagon, now this is meant to be regular, which means all the sides are the same. Obviously it doesn't look like that, but imagine it is regular. I'll put my little lines here just like it is on there. So all the sides are the same, and we have the centre point there. Now I've drawn that line there. Now if I draw lines from the corners all to the centre like so, I want to know what this angle is here, or this angle is here, this angle is here, and so on and so forth. Okay? Now, around a point, you should know that angles around a point add up to 360, and I have 6 of them. And because it's a regular hexagon, I can just divide by 6, which tells me that I have the angle there of 60 degrees. Okay, so what I'll do is I'll just draw that on my main diagram here. So I now know that that is 60 degrees. What I also know is that these two lengths here are the same, because from the centre I've gone to one corner and to the other corner, and because it's a regular shape, these two sides are the same. So I actually have an isosceles triangle. So I want to work out what these angles are here, because I have a theory. So to do that, I do 180, take away the 60, which leaves me with 120, and because it's an isosceles triangle, I divide that by 2, which leaves me with 60. So in fact, this isn't an isosceles triangle, it is an equilateral triangle. Now because it's an equilateral triangle, obviously all the angles are the same, that's what gave us the clue, but it also means all the sides are the same, which means if this is 4, this is also 4, and this is also 4. Why does that help us? Well, we want to know that length, and we've just proven that it's 4 centimetres. Once you've done that, it is just a straight up Pythagoras type question. So there we go, 11 squared is 121 centimetres squared. 4 squared is 16 centimetres squared. So we've got 121 minus 16. Let's just get the calculator ready. So 121 minus 16 is 105 centimetres squared. And of course, I need to square root that to get back to the length, which is 10.246. So the one decimal place is just 10.2 centimetres. So we should also say the square root of 105 there. Been a bit naughty and skipping steps. Okay, so there are some 3 examples of how you can do Pythagoras but in 3 dimensions. Definitely recommend drawing. I definitely recommend highlighting to try and see what your triangles are. And just be very careful if you need to divide by 2 like we did in the previous example, or if you don't quite know, can you form some sort of the shapes? Do you know any rules like we did here? And just try and build up your answer, starting with little diagrams and trying to find out the lengths and essentially working backwards. So hopefully that's useful, guys. Thanks for watching.